Hey, what's up, you guys? Alright, so I wanted to get some new videos out for you guys so you could study for your exam coming up, and I thought I got a few suggestions from people, so I'm just going to go ahead and make a couple now. So, this first one we're going to do is just some more stoichiometry. I want to hit stoichiometry one more time. I already have a video up with stoic, but I'll do one more time with stoichiometry. I'm prepared. I got my calculator here ready. And yeah, so here we go. Let's do it. So let's say we have a reaction with what should we do? Let's do iron nitrate, iron 2 nitrate plus, what should we do? Should we reduce it? Yeah, let's reduce it. Cobalt 2. Yeah, let's go to iron plus CONO3. 2. Good. I'll bring that down a little bit. Alright, so I just came up with that off the top of my head, so, that's what I do. And so here we have iron being reduced by cobalt. So this will be nice. This way, oh, that's not really my favorite. Okay, I shouldn't have done it this way, but there's all like one-to-ones. See, it's easy to come up with one-to-one reactions off the top of my head, but the other ones, tend to, they're there and I just don't think of them. So I'll still make sure I emphasize when we're supposed to use these one-to-one coefficients, because this is the whole essence of stoichiometry, is one-to-one, or I'm sorry, is using the stoichiometric coefficients, which are these guys right here. So let's say we've got 75 grams of Fe, so we've got 75.0 grams of this guy of iron nitrate, and we want to know how many grams of cobalt nitrate we will make. So iron nitrate, how many grams of cobalt nitrate will we make, will we produce? Okay, so we can start off. We're first going to need to do to come up with some molecular masses, but well, we don't have to. Let's just, well, we will. I'm just gonna get started here. Okay, so start what we're given. So we've got 75 grams of iron nitrate. We have to convert this into moles, because we cannot use these. These are mole ratios, stoichiometric mole ratios, these ones right here. We cannot use them unless we are in moles. So going to our periodic table, I happen to know off the top of my head that iron weighs about 55.89, plus nitrogen weighs about 14.01, and then there's 3 oxygens, which weighs 16 apiece. So iron nitrate weighs about 117.9 grams per 1 mole. This is straight from the periodic table, or in my case, just from my memory. Oh gosh, I made a mistake. There are 2 nitrates. I only counted for 1, so hold on, one more. Plus 14 plus 3 times 16. Okay, sorry about that, you guys. I thought that seems a little low. But yeah, it's 179.9. I only added 1 nitrate, and we've got 2 of them, right? So don't mess that. That's the easiest place to mess up these problems, is getting your molecular weight from the periodic table. So now that we're in moles, now we can use, I'm going to run out of space over here, I just know it. But now we can use these mole-to-mole ratios. Now we know that for every 1 mole of iron nitrate we use or have, we get 1 mole of cobalt nitrate out, and that's where we'll put that. 1 mole of iron nitrate, and we'll get 1 mole of cobalt nitrate. So we just have a 1-to-1 ratio. Now, if we start canceling units, there's grams here, start canceling units, these grams go with those grams, and these moles go with those moles, and now we're left with moles of cobalt. Now here's where I don't know what cobalt weighs. 58.93. So cobalt weighs 58.93. So now I need to get the atomic mass of cobalt, which I did from the periodic table. So I type in my calculator, 58.93? Yes, 58.93 plus, now I'll just do all this at once. We've got 2 times 14.01 plus 3 times there, 182, and that makes sense. Good. Yep, that makes sense. 182.95. So I'll put that up here. 182.95 for 1 mole. Now these moles will cancel with these moles, and we are left with grams of cobalt. So we went from grams of iron nitrate to moles of iron nitrate to moles of cobalt to grams of cobalt. So grams to moles to moles to grams. That is how you go. That's how you do these problems. It's very, you can use this as a template. Like, just if you write out this template every time, like just before your exam, if you want to practice, write out this template 5 or 6 times. That's a good idea. And then you just see it and you just plug the numbers right in. You just need to know that like pretty much like right here, this is the iron stuff, and this is the cobalt stuff on this side. Kind of think that division line right there. So multiplying this all out, this answer is going to be multiply all the top divided by all the bottom. So we just got 2 things to multiply on the top because these are just ones, and multiplying anything by 1 is pointless, right? So we'll go, I'll show you exactly what I'm going to do. We're going to go 75 times 182.95 equals that huge number, 13,721. Divide that by all the bottom, but these here are just ones, so I can ignore them. I'm just going to divide by this 179.9. Oops. 76.27. grams. But we're not done because this is not, we're not good with sig figs at the moment. So to make this correct with sig figs, we would just round this to 76 point, we have 3 up here, 76.3 grams. That 7 makes that 2, round up, whatever. And this is our answer. So any stoichiometry problem you run across will be able to be done the same way. You may not be given moles, or I'm sorry,